Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem largest subarray with k sum. Alright, so k is here 0, so we have to find largest subarray with 0 sum. The problem statement says that given an array containing both positive and negative integers, the task is to find the length of the longest subarray with a sum equals to 0. Alright, so we all know what is a subarray. So we have to just find the length of the longest subarray which will give the sum as 0. Alright, now what can be the most brute force approach to solve this problem? So the first approach which comes into my mind is just we can write all the subarrays and just check the sum of all of them, and if sum equals to k in this case is 0. I will solve this question as a general k, taking k as 0. So let's say we can go and try all the subarrays and check sum of all of them, and if the subarray sum comes to k, here it is 0. So if the subarray sums comes equals to 0, then we can just store the length of that subarray and use a maximum variable to just store the maximum length we can find of the subarrays. Alright, so this was the brute force approach. Next, the better approach which can come into our mind, that the thing is subarray here. So the next thing which comes into our mind is sliding window technique. So but the problem is that here it is written that arrays containing both positive and negative integers. So sliding window doesn't work in negative integers case, because what does sliding window tells that if we have to increase the sum in that subarray, so we will move right, but if we want the sum of the subarrays less, we will just shrink the window. All right, so we will, if we have to increase the subarray, we will move right, and if we have to decrease the sum in the subarray, we will shrink the window. All right, so in this case array integers are negative also, so that will also not work. uh, Alright, so sliding window cannot be used. So the last optimal approach which we can use is using hashing. Alright, so I will tell you how we can do this. So first of all, I will just take this example one. So example one is 15 minus 2, 15 minus 2, 2 minus 8, 1, 7, 10 and 23. Now what we can do, we can just take a hash table or an ordered map we can use. Now what we do, suppose we are here. All right, now in general, if I tell you, suppose we have reached an element where the total sum here is x, and we have to find a subarray whose sum is equals to k. So if we are able to find a subarray from the starting whose sum is equals to, if we are able to find that subarray, if we are able to find a prefix sum, let's say prefix sum equal to x minus k, if I write this clearly, if this equals to x minus k, then definitely we will find a subarray here which equals to k. So with this logic, we will keep storing the prefix sums into this unordered map. Alright, so first of all, we are here, we have got 15. So what do we want? Let's say our k is 0 right now. So what do we want? our sum is 15 right now. So x minus k, this will be 15 minus 0. So uh, we have to find x minus k. So we are here, the sum is 15, and in the map we have to find if there exists x minus k, that is 15 minus 0. If there exists 15, no, it doesn't exist. So we will say that the sum is not coming equals to k. All right. So there does not exist any subarray which uh, whose sum equals to k. All right. Now next we move here, and before moving we will store also that 15 we have found prefix sum and its index, that is 0 right now. Now we will move here. Now our sum will be, if I take the sum also, sum previous was 15, now it has become 15 minus 2, that is 13. So we will say now we have to find our x is now 13 and we have to find sum minus k, that is 13. So is there any 13 in this subarray? No. So we'll just move ahead, and before moving we will store also prefix sum. Now next, now the sum has become 13 plus 2 15. So now here we will ask that is there any subarray, is there any prefix sum exist in the map that whose sum is 15. So we will say yes, we have found sum as 15. So yes, we will update our answer. This will be a maxi variable. This will store the maximum length of the subarray which we have found. So we can say that yes, we have found 15 here, and we were taking this subarray, and we have found this 15 also whose sum was 15 and its index was 0. So we can just choose this subarray minus 2 comma 2, which will give us, this subarray will give us sum 0. All right, so we will choose this, and before moving ahead we will just update our maximum variable to store our longest length of the subarray. So this will be just the index. Right now we are standing at, the index is 0 1 2, and the index of this prefix sum, so this was 0. So 2 minus 0, that is 2. So maximum we have got right now is 2. Now moving ahead, and before moving we will store also. And now right now we will not store, because suppose we have now sum 15 and we can also store that sum 15 we have got here till here, that 15 comma 2. We can update this 0 as 2, but we will not update because we have to find a subarray k with the largest, with larger elements. All right, we have to find the subarray k with a larger size. All right, so if we will just say that if we have find some x minus k previously and again we have find x minus k, so we will just increase our subarray and our k subarray's length will be decreased. So we will just not update this now. We will check in the map if it already exists. If some exist already, we will not update it. So 15 is already existing, so we will not update its index. Alright, moving ahead, minus 8. Now 15 minus 8 is 7. So now 7 minus 0, 7. So is there any 7 exist in the array? No. So we will just store 7 and this index also. Its index is 3. Now moving ahead, index is 4. Now sum has become 8. So 8 minus 0, 8. So we will say that is there any 8 in the map? No. We will store 8 comma 4 in the map. Now moving ahead, the sum has become say 7 plus 8, that is 15. So we will just find 15 minus 0. Is there any 15? Is there 15 exist? Yes, 15 exist. So now we can say our subarray can be from this 1 to this fifth. Alright, so we can say we can take this subarray. This will sum up to 0. Minus 2 will cancel. Minus 8 plus 1 minus 7 and 7 will cancel to 0. So now we again got a subarray whose sum is equals to k, that is 0. So we will update our maximum variable, and right now this subarray length will be the right current index 5 minus the index of that prefix sum, that is 0. So 5 minus 0, this will be 5. So this will be updated now. Alright, now we will not update because we have already prefix sum in the map. Now moving ahead, this will be now 25, index is 6, so we will find 25 minus 0 in the map. No, it's not there. We will just store it 25, and the value will be here 6. Now moving ahead, adding 23, this will be 48. Is there any 48? No, there is no 48. So we will store this also 48,7. Now we will just return our maximum length of the subarray, which we can find is 5. So in the answer we can also find that output is also 5. So this is now verified, and the longest subarray is also minus 2 to 7. Alright, so minus 2 to 7, which we have found, length 5. Alright, now I will implement this. First of all, I will declare the size of the array, ar.size. Now what I was using, unordered map, int, int, it's its map, and I was using a maxi variable for storing the answers. So maximum, what could be the maximum subarray length with sum equal to k? That can be, let's say right now minimum can be 0. Alright, if we didn't find any, we can say we can return 0. Now starting I is equals to 0, I is less than n plus I. We will just keep storing sum will be array of I, and we will declare some variable also. Sum will be 0 in the starting. Checking the constraints, so we should use sum as long to be safe. Now what I was checking, I was checking that we have to find x minus k, sum minus k we have to find in the map. So if we find that sum minus k in this case is our 0, k is 0 here. If we find any sum minus k in the map, then we will just simply update our maximum variable. This will be max of max comma the, now what will be the length of the subarray? This will be current minus the index of that map prefix sum that we have found. So this will be map of sum minus k. Now we will update also in the map. So what we will say, if I find this sum already in the map, mp.end, then I will not update. If then I will not update, and if I find any, if I didn't find any, then I will update. Then I will update map of sum, and the index is now index, and at last we will return the maximum sum we have length of the subarray. But right now, what if let's say if the prefix sum it's itself equal to k, what if that condition comes? If suppose we are at any prefix sum where, let's say, we find the array was, let's take and let's find an example. If we find one, so if example was this, all right, so when we will reach here, when we will start, so we will have a map, we will be here. So first of all, k is equals to 0. We will try to find, we are here and we will try to find 2 minus 0 in the map. This will not be there. Now we will update it. This will store 2 comma 0. Next we are at here, we will have sum now equal to 0, and now what we want, sum 0 in the map. So we didn't find any 0 in the map, so this will, sum is now 0 when we are at index 1, index number 1th. This was 0, this was 1. So now right now sum is 2 minus 2 0, and we will now we will find sum minus k, that is 0 in the map. It is not there, so we will say that it's not there, and now just go and move ahead. But we have to take this, handle this edge case, that if we find prefix sum right now, which is coming sum is equals to 0, we have to handle this. So how we can handle this? Either we just store 0 comma the index, what we can store here, what you were just saying, if the whole subarray which we are standing from the starting is itself the sum, so what will be the length? This will be 1 minus this, the length of the subarray is 2 and the index is 1. So what we will say, if we are subtracting I minus map of sum minus k, so if the index is 1, so if the index is I, so suppose here the index is 1, and we have to subtract something, that it becomes the answer becomes itself 1 plus 1 2, that is 2. So what will be x? This will be minus 1. So in the starting we can store that we have 0, we have find 0. If the subarray in the starting itself becomes 2 equals to k, then we have to go and find 0 in the map. So we can store 0 and its value will be minus 1, so that we can easily find the length of that subarray from the starting to the current index. So we will, in the starting, we will just store map of 0 also as minus 1. Now this will handle all the edge cases. Now if I submit this in GFG, submitting is more good. Alright, so we have solved this problem now successfully. And if I tell you the time and space complexity, so time complexity, we can see we are just running a for loop, nothing else. So this is big O of n, and we are using a hash map also, the unordered map. So unordered map, we can say insert, we are finding, so unordered map finds in big O of 1 time complexity. But in the worst case, we know that if collision occurs, this can turn up to big O of n. So but here we are assuming that assuming the average case, all right, that's collision is very extremely rare. So we would say that this is the find function takes big O of 1, and so space takes big O of n time complexity for storing all the elements of the array. So this is the time and space complexity, and we have solved this problem now. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.